In today's lesson, we will be writing algebraic equations. In the lesson, we'll be looking back at sections 4, 5, and 6. In each of those sections, we were given an equation and we were required to solve it. Today, we're going to be given a paragraph for a word problem, and we're first going to need to determine what equation we should use, and then we're going to have to go through the same steps we've been practicing using inverse operations to isolate the variable in order to solve them. So our goal is going to be to create the equations and then to go on and solve them. There are 4 steps we are going to follow as we go about creating equations based on a particular word problem. We'll practice this a couple times and then you can try some on your own. So Carlos is trying to read 12 pages of his book a night. The book has 156 pages. We want to find how many days it will take him to finish the book. Now some of you, as we've gone over problems like this before, are probably already thinking about how you go about solving and finding the answer. But what we have to remember is that our first objective is to write an equation, algebraic equation with a variable identified in it, and then we're going to solve. So just finding an answer is not going to be sufficient for us now. So we first want to identify a variable and what it represents. So if I remember, variables stand for unknown numbers. So in a word problem, the unknown number is going to be the question mask, the thing that I'm trying to find. So when I look back at the word problem, I notice that I'm asked to find how many days it will take him to finish the book. So that's going to be our variable. Just like normal, I can pick any letter that I want. I'm going to choose D since we are working with variables here. So I have D. I need to identify the variable and what it represents. And D is going to represent the number of days to finish the book. And I'm just going to shorthand to finish. So D is going to be the number of days it takes to finish. Now I need to find the total. What number that I'm given that represents the entire amount in the particular word problem I'm working with. So in this example, it says Carlos is reading some pages of a book. The total is going to be that total number of pages in the book, which it tells me is 156. So my total here is going to be 156. The reason I find my total is because I find that it helps me to write an actual equation. In my equation, it should look similar to the equations that we've had in previous lessons in chapters 2, 4 to 6. What we had was we had a variable in an operation with some number and then it equaled a particular total. So my total in this case is going to be 156. Whatever I do on this side is going to equal that. Now I need to write an equation. So I need to think about what's happening in this example and look for some keywords to tell me what operation I should have. It says that Carlos is trying to read 12 pages of his book a night. The book has 156 pages. How many days will it take him to finish the book? Well, I know that if he's reading 12 pages every day, however many days it takes him, I know if I read for 2 days, I would read for, or if I read for 1 day, it would just be the 12 pages. If for my variable D I chose 2, if it was 2 days, I would be reading 24 pages. I know if I read for 3 days then, it would be 36 pages. So the pattern I'm noticing is that I'm multiplying however many days I have by 12. So I'm going to write my equation as 12D equals 156. Now I can go ahead and solve that equation. In order to solve it, I'm going to have to do the inverse, the opposite operation. I'm going to divide this side by 12. If I divide this side by 12, I'm going to do the same thing to the other side of the equation. That helps me isolate my variable D, and it will tell me that my variable D, the number of days that I have to finish the book, is going to be equal to 156 divided by 12. So if I go ahead and do my long division on the side of my page, it looks like I'm going to get 13 as my variable D. Since this is a word problem, I'm not just going to stop there, but I'm going to look at what kind of units I should have. Since my variable D represented the number of days, I should write 13 days as my final answer, and that's how long it's going to take me to finish a 156-page book if I read for 12 pages a night. Let's try another example together. In this particular problem, Jane is on page 79 of her book. The book has 254 pages. We want to know how many pages does she still have to read. So again, I'm going to start out by identifying a variable and what it represents. Again, to find whatever the unknown is, my variable, I'm going to look to what was the question that I was asked to find. If I go back to the problem, I know I was asked how many pages does she still have to read. So this time I'm going to use the variable p to represent pages, and I'm going to identify that p means the number of pages that she has left. After I have identified my variable, I'm going to find the total. This time I'm going to go back and find out, well, if I'm looking at how many pages left, my total should relate to the number of pages in the book, and I was told that that was 254 pages. So 254 is my total. That's going to help me write my equation. Again, I'm going to put that at the end of my equation. At the beginning of my equation, I'm going to think about what operation I'm going to need to do to find out how many pages were left. I know that I was told that she's on page 79. So if I have read 79 pages, and there's a total of 254 pages in my book, if I add the number of pages left to that, let's say p, I should come up to my total of 254. If I then take away 79 to help me isolate my variable p, I'm going to do the same thing to both sides of the equation. That leaves me just p here. I'm going to need to do some borrowing in order to subtract. And it looks like I have 175 pages left. I'm going to need to put my unit left in my book. This is the last example we're going to do together. I suggest that you pause the video at this point, attempt to do this problem on your own, and then when you're finished, listen back and make changes to your example as necessary so you can see how you're doing with this concept. So for this problem, we're looking at a United States population in 2005 that was twice the population in 1949. We want to find the 1949 population in millions, when in 2005 the population was 5 million. So we're going to start out again by identifying the variable. We want to do that each and every time, and each and every time we're going to look for the question that was posed to us. Here they don't necessarily frame it as a question, they make it more of a statement. They tell me to find something. They said to find the 1949 population in millions. And that seems like that in millions might be important to me. So I'm going to identify my variable as p this time for population, although again I could use any letter I wanted. I'm going to say that p equals the 1949 population. I'm going to abbreviate population in millions. After that I'm going to look for my total. So it says that United States population in 2005 was twice the population in 2009. Find the 1949 population when in 2005 the total population was 5 million. So I notice that my total appears to be 5 million. So I'm going to see how I can use that to answer my question. When I go about writing my equation and putting my 5 at the end, I'm going to leave off the word million and save it for the end. That way I can save myself some of those zeros that I have. So now I need to look for what should go on the other side of my equation. So 5 million I know represents the 2005 population. And it tells me that the population in 2005, so this total, is or equals twice the population in 1949. Well, I still don't know what that population is, but if I take the variable I used to represent it and multiply it by 2, twice whatever the population there is should give me my 5 million. Then, in order to solve this equation, I'm going to have to isolate my variable. Since there's multiplication between the number right next to the variable, I'm going to divide to find my answer and to isolate p. And I'm going to have to do the same thing on this side. So I'm going to find some space to do my division. 2 is going to go in twice. I'm going to have some left over. Now I don't want a remainder, so I'm going to add my decimal and 0, make sure that decimal goes up to the top, bring down my 0, goes in 5 times. So I have my P equals 2.5. I have to remember that that's the population in millions. So 2.5 million. I'm just going to abbreviate million so I have room to write people in 1949. Going back to my example, that makes sense. If my population in 2005 was more, if it was twice the population, it should be bigger than my 1949 population by doubling it. 902.5 doubled is 5, so looks like I have a good answer. At this point, you can re-listen to myself going through these steps any number of times that you'd like, and take a look at the additional practice problems following each of these steps to identify first an equation and then solve that equation.